This module covers general information regarding ignition timing inspection procedures. It is not all-inclusive and does not replace or supersede any applicable smog check or Automotive Repair Act laws and regulations. In this section, we will cover some basic information on the four-stroke cycle and the definitions of top dead center and before top dead center. In addition, we will discuss ignition timing, timing control systems, the effects of improper ignition timing, and the ignition timing functional test. You will also have the opportunity to view a video of an ignition timing inspection. For some inspectors, the theory of a four-stroke engine may seem very basic, but to understand ignition timing properly, one must know the basics of engine operation. A stroke refers to the full travel of the piston in either direction, from top to bottom, or from bottom to top. The four strokes are the intake stroke, compression stroke, power stroke, and exhaust stroke. Top dead center is the point when the piston has reached its uppermost position or the top of its travel. As illustrated in the picture, top dead center is represented as 0 degrees. This could be found on the harmonic balancer, flywheel, or ring gear, depending on the vehicle. Before top dead center defines the position of the piston prior to reaching the top of its upward stroke. In most cases, spark timing is measured in degrees before top dead center. Most vehicles have a timing requirement that equals a predetermined amount of degrees before or after top dead center based on the manufacturer's specification. This picture shows an example of 15 degrees before top dead center. Ignition timing determines when the spark occurs in the combustion chamber relative to crankshaft position, which is measured in degrees before top dead center or degrees after top dead center. In older model year vehicles, ignition timing is adjusted by rotating the distributor. If the engine is computer controlled, the ignition timing may be non-adjustable. Fuel burns at the same rate regardless of engine RPM. Therefore, in order to effect complete combustion when an engine's RPM and/or load change, the timing needs to advance or retard. There are two basic types of timing control systems. Electronic timing systems are usually computer controlled, and mechanical timing systems are vacuum and/or centrifugal controlled. The computer takes information or signals from various sensor inputs in order to effect ignition timing change. Examples of sensors may include throttle position, engine coolant, mass airflow, manifold absolute pressure, intake air temperature, and crankshaft position depending on the vehicle's system. Computer-controlled ignition timing is the most precise form of engine-controlled timing available. Mechanical timing controls typically include centrifugal weights, springs, and a vacuum diaphragm to control timing. As the engine speed increases, the distributor shaft spins faster. This causes the counterweights to extend outward against the spring tension, which rotates the upper part of the shaft to change the timing. Also, as engine load changes, the vacuum diaphragm pushes or pulls on a rod to rotate the advance plate to change the timing. Proper ignition timing is critical to the operation of an engine. If ignition timing is advanced beyond the specification, it will increase emissions and may cause engine damage. If ignition timing is retarded from specification, it can cause poor engine performance and/or reduce fuel economy. If the timing is adjustable, inspectors must check the base ignition timing using the vehicle manufacturer's procedures. Many manufacturers provide timing procedures on the underhood emission label, but some do not. If the procedures are not on the label, the inspector shall refer to an emission control systems guide or an appropriate service manual. If there is no engine speed tolerance given for the timing test, the idle speed must be within plus or minus 100 RPM of the manufacturer's specification. For example, if the manufacturer's idle speed specification is 800 RPM, the actual RPM can be within 700 to 900 RPM. Most 1996 and newer vehicles have non-adjustable ignition timing and do not require an ignition timing functional test. BAR allows an ignition timing variance of plus or minus 3 degrees from the manufacturer's specification. If the timing is more than 3 degrees from the manufacturer's specification, the inspector shall enter F for fail into the EIS for the ignition timing functional test. If the manufacturer has an ignition timing variance, BAR's variance is not applicable. For example, if the manufacturer's specification calls for 10 degrees before top dead center plus or minus 2 degrees, then the timing must be between 8 and 12 degrees before top dead center. All vehicles have specific procedures that must be followed to properly check the timing. Consult the underhood emission label or manufacturer's publication and service manuals to identify the correct timing procedures. This photo illustrates a special procedure to check the ignition timing. As indicated on the underhood label, this Toyota requires a diagnostic connector to be short-circuited to perform the timing inspection. If no underhood emission label is available, the timing procedures can be found in the manufacturer's service manuals, ECS application guides, or online application guides, such as ALLDATA and Mitchell. On this 1990 Toyota Camry, the jumper wire is installed into terminals TE1 and E1 of the diagnostic connector, which disables the computer's controlled timing function. This allows the inspector to check the engine's ignition-based timing. The process of checking a vehicle's engine timing is similar for most vehicles with adjustable timing. There are many different manufacturers of timing lights, but most work the same and connect to the vehicle in a similar fashion. The timing light shown in our example uses a device known as an inductive pickup that is connected to a spark plug wire. Most timing lights connect to the engine's number 1 cylinder spark plug wire. The timing light also connects to the vehicle battery. Every time the number 1 spark plug fires, the timing light strobe flashes in order to illuminate the timing marks. It is the inspector's responsibility to verify that the engine timing is set to the manufacturer's specification. On most vehicles, the timing marks are usually on the front of the engine and on the rotating harmonic balancer. Other vehicles might use the flywheel and bell housing or ring gear and bell housing for timing marks. The ECS guide or other manuals will provide the inspector the proper location. When the timing light flashes, the marks on the indicator should align to confirm that the timing is set to the manufacturer's specification. The photo illustrates timing marks that are aligned at 10 degrees before top dead center. It is always important to refer to the vehicle manufacturer's specification and timing light operator manuals for specific information. If the timing cannot be measured due to a mechanical defect, the inspector shall enter fail into the EIS for the ignition timing functional test and follow the EIS prompts. The inspector should be sure to document the mechanical defect on the vehicle inspection report and the consumer's copy of the final invoice as referenced in the smog check manual. The most common mechanical defects are a slipped harmonic balancer or a broken timing indicator. Here are a few examples of specifications from an ECS application guide. Pay special attention to the footnotes since these can change the timing specification. Notice in this example, footnote number 2 indicates a jumper wire must be installed on the engine check connector. As always, if you are unsure about proper procedures, check the manufacturer's specification manual.
The vehicle's base ignition timing shall be checked using the manufacturer's procedures. Many underhood emissions labels provide procedures and specifications for checking ignition timing. In this example, the ignition timing is computer controlled, and as the underhood label indicates, the base timing is 10 degrees BTDC, before top dead center, with the diagnostic connector short-circuited in order to check the base timing at idle. The timing needs to be within plus or minus 3 degrees of manufacturer's specifications or within the range provided by the manufacturer if specified. The timing needs to be checked at idle speeds plus or minus 100 RPM of manufacturer's specified idle unless otherwise specified by the timing procedure provided. Procedures can also be found in the Emissions Control Application Guide or an appropriate service manual. Vehicles listed to have not adjustable timing and/or vehicles with computer-controlled ignition systems that do not have timing adjustments are exempt from the ignition timing test even if the timing specifications are listed. Any mechanical defects where the timing cannot be measured will be entered as a fail for the ignition timing portion of the smog inspection.
Thank you for viewing Module 5 of the California Smog Check Program Training Series.